Hi, everybody. My name is MT Turtle. I'm here with Happy Face, and this is No Mind Radio. We have a wonderful show for you today. It's about the age of the Earth.
Pretty amazing topic, isn't it? Yeah. I'll bet you've got some questions. Our listeners have questions, don't they? It's an area where a lot of facts are which don't fit with the story, right? I think we could talk a bit about it, but there's a climbing mountain of evidence which shows that we were on a smaller Earth, mate. And if you could imagine just for a moment the material of the Earth, yes, having the capacity to expand.
So
yes?
What you're saying is our planet, where it currently is, it wasn't as big as it is now. It actually grew.
Yeah, its mass hasn't gone, but its size has. Because, like, if you've got water locked up at 42 degrees basic overall, and a lot of water is locked up at a temperature such, yes, it's locked. So you've got water, imagine just for a moment, locked up in a state. But if you give it temperature, it could expand 1,500%, and it can push itself out, yes, which it has. And what happens is that at the sea ridges, things grow there, and there's very new rock made, and it's pushing, and it's only 5 miles thick, and the continents are around about 37 miles, let's say, and it's pushing against the continental plate, and the sea plates are only 5 miles thick, but it's much more dense, right? So, but it's 5 miles thick in relation to 37 miles of continent, and it's pushing, as it grows, it pushes these continents apart from each other. Right.
Let me ask you this. Will the continents ever be pushed so far that they are all connected again?
Yeah, like so Turtle Island or America will be eventually closing back over toward Europe. Yeah.
Wow.
Yeah, so that all of those things could be seen, and you could time-lapse things into a future moment and see where things have gone. Yes, but it's static relative to what's going on now, but what could go on in the future, it is really because asteroid, when they hit, they boil the Earth, and they cook things and pressurize it more, yeah? And in those moments where we're expanding. Right.
Okay, well, let me ask you this.
Well, we did expand in those various moments, and it sort of slows down a bit. But
okay. The show, right? Age of the Earth. How old do you think the Earth is?
Well, when you look at the sea floor, you can see that things fit more into 1,000-year cycle more. Venus only got into the orbit where it is in recent time, and we've got evidence of this. And when was it, in fact, that calendar absolutely did have to be changed, and went from 360 days in the year to 365 days. We went 5 days much further away a bit in that time frame relative. It's that you could see accounts and everything that relate to Venus wandering in the heavens, and then coming close to Mars and pushing Mars close to us and things, and then huge terraforming of the Earth occurring because plasma discharges happened, and it carved up huge, rivers and all sorts of things itself, you see. Magma comes along and covers all of that over, the escarpment. So escarpments that are actually looked at that you could see, there's few, and those are things where you can look, you could find bones and this sort of thing of dinosaurs and our species living together.
So how old was the Earth?
Well, when we look at the oceans, what we just said was that you can go back over 80,000 years, and now you're going to see next to no oceans whatsoever, none. You can only see some deep holes and lakes. And time before this and during this time, of course, we have a black sun because we're connected more to Venus. And we only have a horizontal sort of light sun, diffuse, and we don't have light or day, basically, during that period of time. It's sort of just a diffuse light, but we have quite a vapor in the time frame of this, and ultraviolet light doesn't get through much. We have giganticism during this period of time. And so, Venus and Mars and Earth and other planets were all connected to Venus. Venus is a watery sun. It's like a watery body's hit a sun body. It becomes a water sun, and that's what Saturn is. So Saturn's really only 7% the density of water, okay?
What is?
Saturn. It's only
Saturn?
7% the density of water overall in a size.
7 or 70?
7.
Okay, so are you saying the planet's 80,000 years old?
It's gaseous, and our planet formed and was a satellite of Saturn, and Saturn comes in and between Jupiter and the Earth when Jupiter was 1.3 astronomical units from the Earth, meaning it's a unit that the Earth is now is an unit. It's called an astronomical unit. And so that measurement, you could imagine, was 1.3, where Jupiter was. And Saturn comes in and leaves the Earth in the orbital plane that it was of inclination, which it was where Saturn is, and it's sort of related. And it leaves it tracted in space as it pulls back out. And it pulls Jupiter back out to be where it is today, at 5.3 AUs. And it leaves Earth where it is as it does this, you see. And Venus gets knocked loose during this period of time and is wandering, and often is related to as a comet because it's moving and it's
Are these
got a big
planets?
vapor
Are the
behind.
planets alive?
A planet, you could say, is alive when it comes to be a flat disk of material, and then that coalesces back again, and it coalesces into a liquid core, molten core, which now the outer crust comes to be cooler and becomes solid, and now you have a dynamo inside which generates its own energy. So the Earth has terrestrial energy which it generates.
Okay, so I've asked you this many times. How old do you think the planet is? What is the age of the Earth?
Right. Well,
can you give me a number?
Well, we can not say 4 billion years. That's ridiculous, couldn't we? But how would you? Because what we're asking right now is something scientific a bit, which we could talk a bit about, but we'd have to have an observational reference point to start from, wouldn't you?
Okay.
Yes. So would you start out in the Oort belt where Earth formed and know how a planet forms out there, sort of thing?
Sure.
As a wet body, as it comes in and it comes to be comes in with Venus, and then Venus gets captured by our solar system, and slow but sure, Venus comes to be where it is, and so does
Is the Earth 1 billion years old?
Okay, so when we talk about this, we could start talking about, did we live with the dinosaurs? I think it's a better question.
Okay.
Because what we just said was, you're asking a question that someone was there to know what was in the mix, right?
I guess.
Oh, yeah, no, you are. All these questions, which is very important, is scientific, because what you just asked was a question that someone has to have an observational reference point for. So where would you start as far as that's concerned, you see? Because
me personally,
dating...
start at the sun.
No, yeah, because you could start with knowing, did we live with dinosaurs and what happened in the last 1,000 years? I think the questions that relate to what went on the last few thousands of years, honest to God, I personally think that's way more important for you to understand than big questions like how many stars. Tell me right now.
I would never know how many stars.
How many stars are in the universe?
I would say 50 billion.
Yeah, but you see, like, this is going to cause you to have a transderivational search for information to go into a trance, isn't it?
I don't know.
Yes, it is. Like, if I said 65 million years ago, you're going to go into a trance too, aren't you?
I probably, maybe.
Of course you will. And then
Your voice is very hypnotic.
But what happened 1,000 years ago, 2,000 years ago, 10,000 years ago? But let's link it to some of the major events that occurred.
I'm just trying to give the audience an idea of what you think or how old the planet is.
So, for instance, let's just look at fingerprints of, we know that supernovas, these are suns that get, blow up and this sort of thing.
Sure, yes.
Right. Well, what's the reason why that we would only have ever found like maybe 300 fragments relative of this? And in all the time span, is it just that these things just dissipate? Yes. And so once they've dissipated, how would you know? You see, so but if you knew that space is rolling over in columns and things are neither going further away or apart or whatever, but rolling around in columns and of space, you see, and there's massive columns of space that are rolling around, could you make sense of what that is? You can to some degree, because we're all falling into the zone of avoidance. We're falling south.
They say our Earth is, or our planet, or our solar system is expanding, right? No?
Look, again, if you could say that we're expanding, is it because you're just rolling on some plane, rolling away from another plane that's rolling away from you?
Maybe.
Well, how would you rule that out?
You can't.
Okay, so that's the fact of the matter, because you're not looking at a flat plane, you're looking at 3-dimension at least. So let's pop outside our solar system, and what are you looking at? And let's describe it.
Okay, you would be looking at a bunch of stars.
No, you're not. You're looking at our solar system.
Our solar system?
We stepped out the solar system, not our stars.
Okay.
We're looking back at our solar system.
Okay.
Right, and that's the planets and the sun.
Okay.
Okay, so you've just stepped outside.
Okay.
Now you're in space. You're looking at the sun. What's it doing?
It's spinning.
Well,
No, it's exploding.
No, you see what I mean?
What?
Okay, can you
shooting fire.
no? Now listen just for a second, so we can really grow up about it.
Okay.
All right.
Yep.
Have you ever seen a tornado?
Yes.
You really have seen a whirly?
On
No, I'm
television.
asking you. Have you seen a whirly?
Not in person.
Okay, but you can see a tornado and a whirly. Yes, in your mind.
Yep.
Okay, so now you're down at the base of that. Can you see a sun?
Yes.
Okay, so now let's just relax, because you're just looking outside the solar system and you're seeing that the sun is falling pretty fast, 450,000 miles per hour.
Wow. Never thought of it like the sun is falling.
Of course it is.
Wow. Never thought of the sun falling.
Well, yeah, but just relax, because if you've only got a table and you're looking at a flat thing and it's a diagram, how the hell can you actually see what this is?
Well, my mind.
We must be able to visualize these things and see them, and as you can, this is going to help a lot.
Okay.
So first, when you're stepping outside the solar system, you're looking at a tornado, and it's just falling through space, and the southern end of it is just falling south, right, into the zone of avoidance, like everything else is too, right? And something is north and something is south. Okay. Let's be really good about it, because you've only got 3 particles. You've got a south positive, a north negative, and a neutral, and that's it. You see, and all this other stuff is a bit bull dust. But when we're looking outside the solar system, you're looking at a tornado and you're looking at curl-back regions, and right there where planets are, you've got a law, which bodes law, which fits to be like relevance.
The dust up that the tornado makes.
When you've got a tornado, you've got curl-back regions as you see the funnel. The funnel gets out, doesn't it?
Yes.
And you've got curl-back regions in that funnel, don't you?
Okay.
And in those curl-back regions, you have a planet. And now all the planets, what are they doing? They are falling behind the sun.
Okay.
Thank you so much.
So the sun's taking us with it.
No, look, do the planets go in front of the sun?
I don't think so.
No, good. They are falling behind. Thank you so much. Now we're getting the right perspective.
That's pretty amazing visualization. I had no idea that that's what's happening, I guess, right?
Well, when you look at things more two-dimensionally, like I do, you could see everything, and you could see how the whole thing works. But I've got to go beyond just one dimension, two dimension, or something, because you've got to make it real.
I can see it.
A piece of paper is only 2 dimensions. Hey, you and I, we're 3 dimensions.
The vision I got in my mind is amazing.
Okay, good.
You painted a great.
So now
picture.
You're going to see that these planets don't ever always in the alignment or orbit that they have in this moment now at all. And things are not fixed whatsoever, not proper like that at all, but variable, quite considerable, matter of fact. Yes? And so the various things can happen, can't they?
Yes.
Because you've got various things get broken up, and small butterfly effect can happen where something gets broken up, smashes into something else, it causes it to deviate, smashes into something else. And you've got these sorts of things going on. And so between Mars and, Jupiter, you've got this huge belt of asteroid there, and it's full of asteroids and things.
Yeah.
But the basic thing is that, like, we've got these suns blowing up, and it's like, they're going off all the time. But how is it that if stars blow up every 30 years or so, how come we can only find the supernova of all of that? Maybe only 300 somewhat of them. So it's really, where's all the rest of all that material gone? I mean, in a few thousand years of remnants that's left, and nothing is afterward, but all points really at the moment to a much, much younger Earth, okay?
Wow. Okay, so much, much younger Earth, and guess what? Aren't there much, much older civilizations than what we're being, or that we know about? I mean, there's some really ancient stuff out there that hasn't really been explained as far as I'm concerned.
Well, there's an amnesia that after these calamity, and then after the calamity, people got left of what they had recorded and things. But many things that would be made or would be diminished and gone, and you wouldn't find anything. If a tsunami hit Turtle Island, you'd see Mount Rushmore, but you really wouldn't see anything, because there'd be nothing left in 2,000 years, you see. You wouldn't find anything. Not any of the materials that we made, basic or anything much, no, you see. But what would be is the terraformedness, but maybe not, because magma and all kinds of things flow over that, you see, yes, and changes the topology. So when you're looking at escarpment, we're only going to find bits and pieces that would cover a full billiard table, that sort of bones of ourselves and this sort of thing, you see? And so there's a lot of extrapolation going on.
Well, and when you look at like the Ice Age, right? As soon as everything melted, a lot of these civilizations that were lower, built lower in the, I guess, closer to the sea.
Always. 90% of our population at the moment lives more 1, 2, 3 miles away, from the coast. And tsunamis go in at least a mile or more often, you see, on average. But look, if you're looking at, for instance, like stars like the dog star Sirius, for instance, is it now looked upon more as like a white dwarf star, for instance, for instance, the planet Jupiter is cooling and continuing to cool, and that spot is slowly diminishing more. But was Sirius, for instance, like in the heavens, in the northern heavens, wasn't it not known more as a red star in the past? You see? So what goes on over time it is, but of course, like Andromeda, it takes 1 million years of light to get to us.
Damn.
So they only could see, if they were looking through a telescope, what was happening 1 million years ago today. You see, so light is a very slow slug, basically, really. You've got a quadrillion Jubb constant units in a light second, a quadrillion units in a light second, you see. So, but Jupiter's cooling, and so it's cooling, and it can't be billions of years old. All right?
What?
No, that's impossible. Okay, because there'd be nothing left of it. So let's just relax about this billion stuff for a moment,
Okay.
Doesn't mean that something has gone on and past has been and where time is. But if Jupiter's moon, Ganymede, for instance, it's got a magnetic field and it has a liquid core. And most today don't really even know how blood is formed in our bone, or even how a natural birth is. And these are things which we need to learn more how to have proper inferences, for instance.
Let me ask you. Oil comes from our planet. Is oil finite, or is that the blood of our planet? Does it keep making more?
An infinite amount is existed of such, and hydrogen and carbon, basic is simple, and these things come together at pressure, and so we can have combustion engine if it did, but it's heavy element to run and make, when you don't need to, when you can have something in the wheel which is direct. These are things which is going to happen more, you see?
Sure, but my question is oil finite, or
yes.
does the planet create more?
Yeah, it's continuously being created more.
Oh, that is see, a lot of people don't know that.
You say, what's the age? Anyway, I mean, perhaps it's not wise to think of something as a fossil, but you put fossil in front of something, you can imagine some scarcity. If you have scarcity about a commodity, do you think people will pay more for it? Yes, they will. And so where you have a monopoly, truth isn't existing as it should be. Certainly we could have clean energy, and the companies and things that's all caused petroleum and stuff when clean energy is, there's a lot of a mess as a result of it, isn't it? But if you come back just to the idea of how old the Earth is, back in the topic again a bit, like how you've got soft tissue that's found in dinosaur made, you see? Yes. So how do you explain that? You've got a problem really where people could say that something is millions of years old, which couldn't be conceivable because you're burying a fact when you do that, because it's discovering where soft tissue really is, and all sorts of DNA and RNA and things which absolutely did come from that species are being examined. Very fragile, and the problem really of deep time made up is something which has been groupthinked by one people, a monopolisation, which is really like a criminal banking cartel of a one world order, more or less, and the people who run that, which is a great council, and so they own 194 corporate nations and have done so for quite some time, and so you and I, we could not be necessarily being told the truth, because an obfuscation of the truth is there's too many things like 9/11, the pipeline, all sorts of things which we know did occur, and we even know how that happened, and that isn't the official view, is it? Like we went to the moon, for instance, or something. But so it's a problem because you've got soft tissue, which absolutely couldn't be found in a millions of years old fossil. And it's a brick which is really getting into the current story right now. And it's causing what was a paradigm paralysis to be suddenly all of a sudden just like bricks in a wall that don't fit. This brick in this wall causes the bricks which is there to all crumble down. So, like, you've got a contextual validity, of course, because you've really got descriptions, quite a bit, matter of fact, like radical, all over the place of dinosaurs. And then we just come up with the name dinosaur. Sometimes it was just interpreted as a cow because it would be as a word like beast or something, you see, like a four-legged beast or something like this. And it sounds, but you've got sounds like a Titanosaurus or a Ceratops as a tail, because it would be as fat as a cedar tree used to be. They'd make those temples with those huge trees, and these tails were as fat as that. So it's just a tail of an elephant's little, isn't it? Right, but not as fat as a cedar tree. You could explain, of course, Turtle Island, the last ice age and what have you, and how things survived to be relative, and must have, because you've got soft tissue and blood and all sorts of things today now found in dinosaur bones, you see, and they're all carbon-14, and up to a certain degree, how much carbon-14 was existed and things such like that. And then on an average and relative, that's something that could work up to a certain point where age is relative. But then all other sort of dating techniques and things such like that where rocks are, it's just really quite radical when you start to extrapolate something which is going to have a half-life, but it's over 1 million years, let's say, or 500,000 years, or, to be understanding something that's old, when those are techniques and things which is extremely unreliable. But you've got C14, and up to a certain degree, when it matches with a contextual validity of other things around it, you could start to build a picture more. So, why would there be maps of the ice-free Antarctic? Can you see when Tasmania and the Antarctic and the American continent were together, and Tasmania was in between, and it's just now left below Australia, you see? As a remnant of the past.
Sorry to interrupt, but let me ask you when they drill in the ice, are they able to age the ice the further they go down?
Yeah, of course. You can go down 12,000 years ago when an atmospheric explosion occurred above the Hudson. And that's pretty big. That did knock the Earth over and change the equator, which the North Pole used to be in Alaska. Okay, so after that, it really set fire to everything. We had trees like Devil's Tower, which you can have a look at. That's how big trees were. All the forest gone. We don't have a forest now. But if you can imagine in the ice, a secret exists in the Antarctic and places like this, yes? And you go down to this time frame and you can find massive amounts of soot and carbon and what have you. It's just incredible. Now, how much do you find? We're only going to measure just like what we could estimate what fell on the land, but a lot fell on the sea and melted. All that be left on the land sort of stayed and slowly melted away. But you could imagine just from the amount of carbon and soot that was found in that layer, a secret exists of the amount of trees that burned. Now, if you look at all the trees and greenery all around the Earth right now, we could all put it into some size and we could say, okay, so that's the size of a loaf of bread. Okay, so in relation to what was burned would have been a semi-trailer's worth. You see, back then. So we had a forest back then, and so would you imagine where did all this carbon come from? It was like, yeah, that's right. Trees were huge; they'd be miles up into the sky in the days past. You see.
Let me ask you: would you say the Earth is old or the Earth is young?
When you say the Earth is old, are we talking about the ocean, or are we talking about a tree, or are we talking about dinosaurs? Are we talking about when something came along? I mean, what are we talking about? Just like a rock
in its early 20s, or is it
I think the thing that you
70s?
could give an example first that, you could see a watery orb, which we are a watery orb formed of ice and water and rock and dust and stuff, and formed in the Oort belt out there, slowly brought in, but came in with Venus as a solar system, and we had a black sun back then, which we're living in the fifth sun, and so that's changed. We've got a light now, which is like a daylight and dark, where we didn't have that before. In the story and things, we have a black sun. And so we must explain some of these things, you see. But you've got things that go on like the flood, the last huge flood. And so when you date something, wouldn't you like to know when did civilization reboot and have to start again?
Yeah, that'd be
so,
fun.
Wouldn't you like to know what was existing before this? You see, so these are interesting questions.
Sure.
So, for instance, like in 2807 BC, you've got Noah's flood, and you've got that flooding into the Black Sea, and you think you've got all the water being poured out of the Mediterranean when that happened. You've got a massive tidal wave that floods over the North America from east to west and pours out and floods more sediment over the old civilization that's in the ocean there now, below the ocean, which sunk sometime before this. So if you could just think like, okay, so just think for a second, because it'll be good. When you say, how old is the Earth, you're I'll say, can you see the forest? And you'll say yes, and I'll say, no, you cannot. Until you can say you can see a tree, good. Can you see Mary? Yes, you can. Can you see America? No. Okay, when you say America, there's three definitions of America, isn't there? There's the land, there's the
government,
there's the constitutional republic, which is called America, and you've got a corporation of America today. Most people are talking about a corporation of America today when you say America. But might you not be? You might be talking about from the land. So it's like when you say Earth, this is an extreme nebulous kind of a condition, because first you've thought that exists in a way, and it does. Well, it does, but it's undefinable per se. So when you're saying what part of the Earth or what something is, and then you ask me, what's older, I'll say, well, water is older than the sun. Okay, so things like that you could actually know.
Water is older than the sun.
Yeah, but let's get a bit of a usefulness out of our conversation today, a bit to wrap it up as we can, because people can get some nitty nitty-gritty a bit, yeah?
Sure.
Yeah, so the
Let's give
younger,
it to me.
drier era happened, didn't it? And then we had an ice age, didn't we? When was that? 12,000 years ago till about 10,000 years ago.
Okay.
And then it busted up, didn't it?
Yes.
So it was 10,000 years ago. How long ago was that? That's about like 8,000 years, isn't it? So 8,498 BC, on the 5th of June, we got smacked into the ocean a bit, like with an asteroid that broke up, yes? And it sunk Atlantis, didn't it? Okay, so then, the Richard structure and all these parts of everything, and the southeastern sunken plateau today was above land there, and you see a massive city where Atlantis was. Time passed since then, and we've got the Atlas Mountains and people actually really starting to actually really be right there. That all of Africa is only a really small little bit of land called Africa, and it's just below Italy. And it's just a small territory it's called Africa, but the rest of Africa is a conglomerate made up from the Kush, the Moor Empire, made of a conglomerate of people from all over the earth, because they had boats, and they had the primary boats that went back into the 10,000 BC and things, and so when in 2807 BC, when Middle East gets wiped out, it gets wiped out. You see, it gets reseeded again and comes to be called Canaan from Canada. And the language of the Canadians bring that new language to Greece and start that all civilization there. So you've to be able to relax a little and start to think more like about something specific. Because when we go to something like the age of the earth, you're talking about it like a cow. And how old is a cow?
Correct.
Okay, so, well, how old am I? Maybe 7 years old on average.
Okay.
Why? Well, because you just asked how old I was in my material, didn't you? But how old is this thinking can be eternal, more I is, and wasn't just start when you're born or die, and it would witness your birth where you are, you see? So these are the questions which we could get into a little bit more, but it'd be better for us to know, okay, we had an ice age, and we were much closer together back then. We've grown so huge, the earth, in the last 10,000 years. We've had a big flood, and the flood happened in 2807 BC, yes? I mean, when that happened, that was a big reset, yeah? Mm-hmm. You've got all kinds of things going on there, which we have evidence of, well and truly, and so we can understand that sand got washed over the Sahara, and finally the Northern Africa no longer existed, which it did, right?
By the way, they're seeing greenery growing in Sahara now. Isn't that crazy? No,
it's not. See, because things are not fixed. When you blow up a volcano below the ocean and you get 10% more moisture, and you did that synthetically, now you've got 10% more moisture in the atmosphere. For the next 20 years, we're going to have a lot of hot, plus we're going to have a lot of rainfall and precipitation because of it.
Okay.
You see? Yes?
Now let me ask you this before we wrap it up.
Yeah.
Is climate change real?
It's certain that in time past, where anybody could have collected a temperature, they weren't able to. And in a little spot here, a little spot there, how did they average that out? It's a difficult thing to do. That's the first thing.
Okay.
So no observational reference point was there before, because, like, if you could imagine in the statistics that's kept, it shows that there's been years where the average temperature of the Earth has been hotter by 2 degrees. So when you go to start to talk about things like this, certain it is that what would be a reason for climate changes to be involved, where, you've got ELF wave, and you've got particulate being put up, and you've got 10% of the radiation of the sun being blocked, and these sorts of things are not being used to actually cause the weather to be changed, like a yacht race to be won because somebody just made the wind to be able to be where it is. That's a weather warfare, as you're pointing out, is big time, huge.
Is humanity causing or affecting climate change in any way?
You and I, when we know that a piece of orange peel that you peeled and put it as you went to the temple is going to maybe last there for 6 months. And so it's as an eyesore, it's a bit of litter. See, the orange peel is going to take time to break down. How long does a piece of paper take to break down? How long does plastic take to break down? What's the reason why we don't do life plastic right now, you see, and move toward plastic which doesn't, toxify and actually have packagedness and things that's like that? We must actually think more this way. But if you and I were more in charge, we'd have these things, and we sit above the Legislative Assembly of the state, and so you can affect policy. But when did people do that? This is what needs to happen, you see, because otherwise you've only got corporate stuff.
So humanity is affecting climate change?
Of course. I just told you that usury impacts everything. I just told you that if you cut all the trees down and you don't know that shade is important, like when they just had, they're going to chase lamb butt, for instance, people chasing lamb butt, but it takes 5,214 gallons of water to get a pound of produce from lamb butt or any other sort of butt that people eat as flesh, where it only takes 22 gallons of water to get a pound of produce from tomatoes and 70 gallons of water to get a pound of produce from grapes, which is really inefficient because you get a bottle of grapes out of that vine. It's like, oh my God, it's a massive waste, a lot. But it is a waste when you look at flesh, all flesh, because 90% of all the grains grown actually goes to eat the flesh, and then you're eating flesh. It's like, excuse me, this is outrageous. It takes 5,214 gallons of water to get a pound of produce from flesh. So would you do that if you knew, you and I, you're voting in the art of the way you're living your life by what you're purchasing, Caesar? You see?
Folks, as you can see, we have a lot to discuss. That's it for today.
And dyspepsia, which lemon and butter. Guess not to say you're getting.
Hello.